Hello, this is Mrs. Often. I'm going to be reviewing in this slideshow the content for measuring segments and angles with focus on the definition. This correlates to Unit 1.1, which you can also see as a PDF file. So I've broken this up into two separate slideshows and two separate videos, or you can read the entire PDF. So by the end of this slideshow, you're going to be able to define a whole bunch of terms in geometry. You're going to be able to create and interpret diagrams using them. Those include point, line, plane, segment, ray, angle, endpoint, collinear, and coplanar. You're also going to be able to use the Ruler Postulate and the Protractor Postulate along with segment addition and angle addition postulates to solve problems involving segments and angles. So let's get started with some definitions. So I want to point out undefined terms. These are terms that are taken for granted in geometry, especially Euclidean geometry, which is geometry on a flat plane. We start with the point. A point is a location. It has no size. Please note that we have this diagram here that has the point. It's a little dot, has a capital letter next to it. It is notated with a point P. A line is an infinite number of points in a straight path. It extends in two opposite directions with no end, and it has no thickness. You'll see a drawing of a line right here. It also has a little cursive letter next to it, line L. We can call this line L, or we can also name it using the two letters AB, or I can name it BA, both of those with the line symbol above them. A plane is an infinite number of points, and it lies on a flat surface. It extends without end, and it has no thickness. So if you can imagine a wall going on forever and ever, that would be a plane. Notice this plane has 3 points. Anytime we have 3 points, they automatically define a plane. Those points are X, Y, and Z. So I could name this plane XYZ. I also could name it plane ZYX. The other name I could give to it, it comes from this capital letter that's all by itself over in the corner here, plane M. So we're not going to mix those letters up. When we name them, if they're next to points, we can name it plane XYZ. Or if they are next to the corner of the plane, or what appears to be the corner of the portion of the plane all by itself, you name it that. Okay, moving on to our next slide. Moving on, we have our defined terms. Segment. A line segment is a part of a line that consists of 2 points called endpoints and all the points that are between them. It's notated like this, A, B. Those are both of the endpoints. We could also call this B, A. A ray is also a part of a line. It consists of 1 endpoint and all the points of the line that are on that same side as the endpoint. So here I have ray MN. Please notice that the ray symbol points to the right. If I wanted to refer to a ray that was pointing to the left, I would start with my first endpoint or initial point, and then I would name a point that the ray passes through. My symbol would still point to the right, and I've noted this down here. Opposite rays are rays that have the same endpoint that lie on the same line. So here I have opposite rays TS. You can see TS is pointing to the left, and TU. They must have the same endpoint, so even though US and SU are pointing in opposite directions, they don't have the same endpoint, so they're not opposite rays. An angle is formed by 2 rays with the same endpoint. So this endpoint is then called a vertex. Each ray, in this case QR and QP, is a side of the angle, and again, that common endpoint is the vertex. Please note that there are multiple ways of naming the angle shown here. I can name it angle Q because Q is a vertex. I can name it PQR, which tells me the sides of the angle that are involved and is more precise, or I can name it angle 2 because there's this little 2 right in here. If you have multiple angles which share the same vertex, do not use only the vertex in naming those angles. Okay, so moving on. I want you to be sure that you copy the postulates that are used in this section along with the properties of congruence into the postulate and theorem section of your binder. You will be permitted to use this while you are writing your proofs, so it's very important that you keep that. Okay, the ruler postulate, every point on a line can be associated with a unique real number, which is called the coordinate of the point. So you want to think of this as being like the number line. And the example shown here, the coordinate of x is 3, the coordinate of y is 7. We also have the segment addition postulate. Now, if I'm given 3 collinear points lie on the same line, A, B, and C, with B in between A and C, then AB plus BC is equal to AC. Please notice here that I'm talking about the lengths of segments. I am therefore not using the segment symbol. I also have an equal sign. Now the protractor postulate, and I'm sorry, this is kind of tiny. If we are given ray BA, which I'll draw on right here, and a point C not on BA, so there's our point C, then a unique real number from 0 to 180 can be assigned to BC. Later on in the year, we'll talk about assigning numbers larger than 180 and smaller than 0 to describe these angles. But for the purposes of geometry, we're just going to be focusing on 0 to 180 degrees. Now, 0 is assigned to BA, that's the 0 angle. 180 here is assigned to BD. If I talk about the measure of angle ABD, that angle has a degree measure of 180. You can see as well that angle ABC has a degree measure of 60 degrees, and angle DBC has an angle measure of 120. Finally, we have the angle addition postulate. If point D is in the interior of angle ABC, then the measure of angle ABD is equal to the measure of angle DBC plus the measure of angle, if the measure of ABD plus the measure of DBC is equal to the entire measure of ABC. So those are our postulates for this section. And we do have a couple more items on the next slide about congruent segments. And hopefully you're hearing some barking in the background from my dog, Lola. She's trying to be helpful. She is unfortunately not so great at math. Let's look at this. Congruent angles and segments. Segments that have the same length are congruent segments. Notice AB is congruent to CD. They each have 1 tick mark on them. PQ is congruent to RS. They have 2 tick marks. Angles similarly with the same measure are called congruent angles. they put arcs in the corner there near the vertex. Please notice when you're talking about congruency, you need to use that symbol for congruent. Okay, and that's the equal sign with the tilde above it. When we're talking about measurements being equal, we would use the equal sign. So if I were to measure AB and CD, and I knew what their measurements were, I could say AB is equal to CD. Now it's also important to note right here the reflexive property of congruence, the symmetric property, and the transitive property. You may remember these properties of numbers. You will be able to use these in your proofs. They will be especially important when we do proofs about geometric figures. So those are our definitions for this section. I look forward to showing you some examples.